Let's start. I think we have almost 30 plus attendees and overall 40 people. Good afternoon, everyone. Thank you for joining in. Welcome to today's webinar. As you can see on my background, there's a webinar topic, and I'm sure you've got the invite as well. We are going to discuss today about unlocking AI-driven efficiency, modernizing IT infrastructure for next-gen compute. My name is Anup Kubba, and I'll be your moderator for this session. We are actually very excited to have you on this webinar, especially after the success of our previous webinar, which was almost attended by all 80 to 90 technology leaders such as yourself. The idea of today's webinar is basically to explore the vital role IT infra is actually playing in unlocking the full potential of AI-driven workloads. I would not mince word. I'm sure you've heard AI words innumerable times by now since the last 1.5 years post Chat GPT's, bringing of their new GPT version. But as these emerging technologies are, continue to advancing, it is absolutely clear that outdated infrastructure is becoming a significant bottleneck. And especially when we want to achieve benefits out of these AI workloads, the idea of modernizing IT infrastructure becomes imperative. If you don't have such an infrastructure, essentially what you're doing is you are trying to win a Formula One race with a very regular passenger car. This is going to be frustratingly slow and painful. Over the next 45-60 minutes, our expert panel, which I will introduce just in a moment, will explore the pivotal role of IT infra as the backbone of every technological revolution, especially when we are talking about the realm of AI-driven workloads, how breakthroughs in compute architecture for AI, ML, data analytics are actually necessitating need of modern servers and processors to enhance compute efficiency. With the context being set, and I again welcome all of you and finding out time to to attend this webinar. I hope this webinar is insightful for all of you. Just a few hygiene things. Q&A we've kept at the end of the webinar, but you're free to post in your queries through chat, and I'll be happy to take it up as and when the window opens. And along with that, we'll have a couple of questions, during the webinar. They are just to understand the current state of IT infra and how are you looking to upgrade or improve your infra and whether there is any need for it. This will help us understand the current IT situation that you are in. So before I begin, let me introduce our distinguished speakers. I have the pleasure of hosting Ranga sir, Chief Technology Officer, HPE India. He brings in 2 decades of expertise in driving technological innovation. He has been with HPE for more than 1.5 decades. Along with him, I have Mr. Sumant Balakedru, Intel Solution Technical Specialist, and he had got a wealth of knowledge in architecting efficient and scalable solutions. With that, Ranga sir, I'll first pass on the baton to you to introduce yourself and then to Sumant.
Yeah. Good afternoon, everyone. Absolute pleasure to be here on this afternoon, and thanks for joining in. As Anup just said, my name is Ranganath Sadashiva, and my role in HPE is to speak about technology and evangelize technology. And in the relevance of today's topic, I think it's an absolutely relevant topic and really a hot topic to speak. At the end of this particular session, I hope that you take home a couple of indicators, at least in terms of how you can track your next AI journeys. And that's about me. Yeah. Over to you, Suman.
Thanks, Rangnath. Hi, everyone. Good afternoon. It's an honor to be part of Technocrats here. Looking forward to interact with you more, learn more from you as well. So I am Sumant Balekudru. I am an Intel and I'm an industry technology specialist. And I architect solutions for various use cases, workloads that you as a customer see in the market. And of course, AI being at the forefront of all these workloads, we are more than happy to encourage or help you with architecting solutions around AI. So that's what I do. That's my day job. And of course, interacting with you certainly gives us a lot of hope and direction as well. Over to you, Anup.
Thank you, sir. Thank you so much, sir, for those introductions. And I'll remember the word technocrat during the discussion, Suman. I'll quickly share my screen just to set the agenda for everyone so that everyone is aware what we're going to discuss and also help our speakers, be in line. The idea would be to first discuss the challenges, followed by innovations in compute architecture, so on and so forth. So as I present my screen and, the idea first, Ranga sir, is AI workloads, some statistics say require 5x more compute power than traditional application. From your app, your experience firsthand, these heavy compute lifting is actually really pushing the infrastructure to its limit. And how are organizations then managing their infrastructure and being able to derive the benefits out of these AI workloads? What are the challenges they are facing when these demands are pouring in?
Yeah, Anup, this is definitely a $1 million question to many of our customers. But if you were to look at where are we headed from an IT landscape perspective, important to notice that from a data center based architecture and the emergence of cloud, we are moving into a world that's getting more hybrid. I would say, everyone has their presence in the cloud. Everyone has a little bit of data center capabilities. So, on the context of all of this, we should realize there is a change in the way compute architectures are emerging, right? If you were to make a comparison of a past situation, right, where architectures were very centralized, you perhaps thought it was a very complex management activity for people to manage that. If you took security, you could feel that security was in bits and pieces. Somebody did a fort and a moat kind of security approach. Somebody was doing security at various levels. It was very disparate. And the performance requirements of those applications, I would term were kind of inefficient in the context of all of this. But if you cut to what we are seeing today, the architectures are getting very distributed, right? You need to have the presence of your compute across the board, across the landscape, as I say. Management is complex, but the requirement is that it needs to be simple. And the security posture for every given organization is something that needs to be comprehensive and kind of integrated. You have one single posture, and despite all of this, there's always a risk of something going wrong from a security standpoint. And you mentioned about workloads and how workload optimization becomes very important. There are many workloads that are coming into play, and artificial intelligence is the most significant workload that's coming into play. And the way you would want to look at compute and compute infrastructure, people are looking for leverages that enable them to use compute in various sizes and formats. I think that's the context in which we need to look at. But you asked about the artificial intelligence workloads itself, and what is the kind of demands that they bring to play. See, we should look at workloads again from an AI perspective. It's going to deal with a lot of data, massive amounts of data, either to train, deploy, or maintain. So when you're looking at that kind of data, there is a requirement for having a real-time compute available to you, right? Which provides us low latency and makes it easier for the application to pick up on all the data that's available for that. And even within the domain of artificial intelligence, I feel the workloads have different tasks to achieve. Some of them are working on prediction, some of them are using NLP, some of them are running a recommendation engine and stuff like that, right? So in all of this, you're seeing the emergence of massive data sets, need for computing that in real time, and that's going to grow in scale as well, right? And AI, mind you, is kind of works on a parallel processing mode, which essentially means you have a single task and you'll have to get together multiple elements to work together in unison to deliver the outcome that you want to have. And that is something that the new world of the CPU GPU combinations is really emerging. So all of this can needs to happen simultaneously in a way and fashion where you're able to deliver the right optimum performance. So the network requirement becomes important, as I said, because you're going to move a lot of stuff between data and compute. You need that. I also spoke about the compute requirements. Do you have the right kind of compute requirements? Important. Is that compute optimized for AI becomes important. And the demands of real time means that you need to have computed of various levels and dimensions to
Got it.
ensure that you're able to meet to all of
Hmm.
that. So I think all of this becomes severe challenges in case it's not done. And many of the legacy applications that we see or legacy infrastructure today lack this kind of capability, and that's where I think we'll have to think very smartly to see how we can get all of this together.
Thank you, Rangu sir. You really set the context very beautifully. While you were speaking, I noted a couple of points which you mentioned. We needed to be in a hybrid setup, and there is a requirement of massive data sets to compute. Building on from that point, Suman, obviously this is one of the challenges. Data sets are huge. There is
Correct.
latency. Uh, and this question is to you, Suman. Apart from these challenges, what are the other challenges that organizations are facing when they really need to get bang for the buck from these AI workloads, and how do they go about actually navigating these challenges? That we'll leave it with that thought, Suman.
Uh, Thanks, Anand, for that question. So, one of the clear thing that comes out for AI workload is one, it is sort of getting distributed. It is no longer confined to the data center, right? Many of the customer use cases warrant and demand for the AI workload to be present at the place where data is generated. Number two, right? So the moment you do that, you have a lot of compute distributed. So management becomes a problem, as Ranga sir said. Centralized management is what comes out of a platform that is built on that, right? So we, along with HPE, we provide those platforms. We co-design that platform to ensure that even at the management level, you are taken care of when you have a distributed architecture. Now, beyond this, when I say that the AI are moving elsewhere to a different places, there are different networks, right? There are different network segments, one at the far edge, or one at the data center, or one at the cloud, or even for that matter, private, public cloud, so on and so forth, irrespective of training, inferencing, or whatnot. So now the major concern today is that how do I synthesize the data to the place where I want to compute, right? How do I move the data around? While it might be easier for me to say that, hey, we have fantabulous network connectivity, just move it around. But look at from the security point of view. Look at it from the movement of the data from one network to another, right? So today, people are embracing what we call as federated AI, right? Or federated learning, where you don't have to move the data to a central location, but move the model or the workload closer to the edge so that you will actually compute faster and get meaningful insight. Beyond this, the moment you say AI workload, one of the critical problems that people face when you actually putting up in the data center is power, right? So the innovative method to bring down the power and the cost of power when you deploy large scale in IT infrastructure for your AI workloads will mitigate the typical power challenges, because the moment you introduce AI, CPU, GPU combination, the per node power requirement goes up. And because it is crime to let go of the cycles on your GPU, CPU, you would always try to run these nodes at the 100% or 80, 90%. So the power consumption is actually high. So there are innovative methods, even in the data center, in the form of alternative cooling methodologies to bring down the cost of the power and cooling in the data center. So these are the different offshoots or offspins of the problem or the challenges that customers today are facing.
Hey,
I
Anup,
think
just
a
in the
couple of
context of
yes, Ranga sir,
just
please.
wanted to add to what Suman just said, right? When you're talking of this artificial intelligence workload, it's like a small stone into a pond. The ripple impact is spread across the board. Like he said, right, power and cooling become so serious and important because all the kind of compute requirements in an AI world would need, greater than power that you currently see or use in a data center, which means that you will have to resize many of your data centers as well, and look for the optimum power and cooling that's possibly there within the servers of the We have a lot of implementations there in terms of, so we are kind of moving away from air-driven cooling to liquid cooling, immersive cooling, and stuff like that. But that's just one part within the box. But beyond that, from a data center perspective, I think you have to look at efficient cooling mechanisms. You have to look at getting the power also, right?
I've heard
So
about subsea cooling as well.
yes, yes, and a lot of experimentation happening, and that's an emerging place. And seriously, it's just not about looking at whether you have the right compute or right storage and data. It also means that physically data centers have to be up and ready for that.
Yeah. I think both of you mentioned, some of the challenges of energy, latency, data sets. And obviously, Ranga sir, you just recently mentioned that, you need to rethink or resize the data center. Picking on from that point, and I'll probably move to Sumant first on this one. Uh, this is basically, and I'm coming from the technocrat angle, a technocrat or a CIO now needs to architect their overall IT infra, and specifically compute infra. So how do they go about doing this when AI, ML, and data analytics workloads really need a push in terms of being having a better infra? How do you architect it from these angles, as well as from an angle of security, where you've already heard, data being available for millions of insurance customers. A large insurance provider in India had just recently had a cyber attack like this, and the data was out in open. So how do you architect for these things? How do you bringing forward one point is actually future proof in a way?
Perfect. So, very valid question. What is more important is what are the factors we should consider while architecting the solutions around AI, irrespective of the business case and the magnitude of the business case. If you were to look out into the future and say that, hey, my AI workload needs to grow and cater to different use cases, maybe summarization, maybe chatbot, maybe beyond, right? So, irrespective where you start your journey on AI, couple of things that you need to keep in mind obviously is one of them is performance, second is security, and third is the platform resiliency to cater to your requirement on a long run, right? The platform that you invest in, the IT architecture that you invest in should probably be with you on your AI journey in the future, right? Now, how do I future proof it? What are the vectors of measurement, right? When you say performance today, CPU and GPU are the main constituents of AI workloads. Typically, everybody looks at a GPU or AI accelerators as the crux of your workload, right? Now, what is more important also is that you need to have a capable CPU that can understand the AI workloads, right? AI workloads are very recursive in nature, very repetitive in nature, right? It's actually very mathematical in nature. It requires a lot of computing as well, right? So it is important that you stay invested in a processor that is capable of providing you a certain level of AI capabilities right off the box, right? Without having to do any rewriting the code or anything, right? That's number one. Number two, all the underlying interconnects of the data from the CPU to the memory to the GPU, and down to the storage, or from the storage back, and not to forget network, right? All of them have to work hand in hand. So a platform that is capable, a platform that considers each of these interactions and provide acceleration in the form of applications or in the form of the hardware accelerators will constitute or will render the platform better suited for AI workloads and protect your investment over a long run, because AI workload typically is a scale out on modular, right? You start with a small model which might fit in a one single server, and then you realize that, hey, I need to put inferencing or I need to train a couple of more models. You start adding servers. That's where I mentioned that power challenges will start creeping in because it started growing exponentially. But having said that, the interconnects, the subsystem capability on the platform, and forward-looking architecture of the underlying hardware will actually render itself for future-proofing your investment.
Sumant, very nicely put. You mentioned about modular approach, and I'll put this question to Ranga sir. While obviously modular approach is being talked about a lot, but building on Sumant's point, how do you architect and have a modular approach while obviously in the name itself it is modules, in an ever evolving environment such as right now, where you are having workloads increasing day by day, how do you architect solutions, and is modular the way to go, or are we having different approaches apart from that as well?
Yeah, modular is definitely one of the ways to look at it. Uh, you know, Again, just to step back and relook at what we are trying to address today, I strongly believe that the approach needs to be something that's AI native. Uh, AI is such a prevalent technology today that it is going to now have its influence across all the applications that we are going to use. So, whenever you're looking at rebuilding or re-energizing your data centers or your IT infrastructure, I think taking to the AI native approach becomes very, very important. And like Suman said, AI has a life cycle in the way you look at AI itself, right? You could be training some models to your own requirements and doing some RAG kind of activities, and then you could be inferring that. And tomorrow, the inferred content could essentially go out, and you could have another data set that you would want to really work on. It is a continuous process. So, understanding each one of these workloads also becomes a very, very important activity to do. So, I guess you need to look at developing an AI native architecture strategy, right? And as we said, this entire strategy is going to be hybrid for sure. So that also needs to be incorporated into the scheme of things, right? So you're able to build leadership in developing and an hybrid based architecture which is able to do kind of computing today and perhaps scale up to supercomputing and has the capability to do all of what you want to do from an AI perspective, whether it is AI ML training, retraining, in whatever it is, right? The other way I look at it to be modular is, you know, that in our Green Lake Cloud platform, where we enable organizations to start small and then kind of build up in a cloud-like environment, and almost like organizing for additional resources, perhaps also building up in terms of whether you want some containers to work for you, some virtualization to be built into it. So everything seems very, very modular in your approach, and you kind of pay for whatever you consume only, right? You're built only for whatever you use. So that's the essence of that cloud experience that we're bringing to an on-prem infrastructure, perhaps. Why on-prem here, especially in an AI workload scenario? The differentiation is in your ability to understand the data you have, right? If you're doing your own analysis basis the data which is available to a third party source versus you doing it, your own data gives you that edge over others as well. So it is definitely going to be modular. And for AI, I know that there is this chicken and egg story in the sense, right? Do you go after what is the return on investment is what people ask, and many a times
Yeah,
people
that's
struggle.
a question being asked right now as well.
Yeah,
TCO,
people
ownership of
struggle
AI.
to define that, right? So and it's slowly but steadily improving. People are moving in from away from that experimentation phase into real implementation mode today, and I'm sure that will provide the right kind of ROI. So all of this has to be worked through the AI life cycle and with an AI native architecture strategy.
Got it. I think we've got a couple of good comments. One was the total TOC ownership of AI, which you already took up, Ranga sir. Meanwhile, we'll be putting up a poll question. I request to all
Okay.
the participants to please answer. This help us assess where you are in your IT journey. My team would be putting up a poll question. I would request everyone to answer. While that is being put up, and you would see that on your screens. Uh, and we will share the recording of this discussion. Whosoever we need, we would be kind of emailing you the recording so that it helps you. Thank you. You find this discussion to be insightful till now. We'll continue to be on the same path. Uh, uh, this is to you, Sumant. While Rangasar has mentioned about the cost of ownership of AI, how do you see ROI being built? And I know I'm going a little different from the set agenda, but I think that's a very important aspect, and I really want to touch in. Sorry for the last minute question, but how do we see the ROI being built? While obviously, everybody is trying to get modern servers processor, and we'll come to that. How do you see the ROI being measured or actually being the outcome being achieved when you are implementing such IT upgrades?
Great. So ROI, as you all know, is a concept that just doesn't hinge upon the underlying hardware, but more in terms of what is the value that the business case that you're working upon, right? Now, if you were to tie it back to the investment that you are making on infrastructure, on people, on data scientists, right? I do not say that it would take an army to create an AI workload today, right? Today, it is becoming everything is low code, no code, AI assisted, low code, no code, even for data synthesis. Now, having said that, if I were to say that, hey, what is the return on investment? Is it worthwhile to invest in an AI infrastructure, right? For my workload or for my use case, it is important to look at the business use case and the impact it creates. Not necessarily all the time that the outcome that you are trying to drive will have a value that outsurpasses your investment, right? There are times when you are creating a workload that are specific to your internal organization consumption and not for a large scale consumption, right? Irrespective of the journey that you are in, whatever you do from the corner cases or what starts as a science project and then evolves into creating a change and impact to the humankind or a population, irrespective, AI, as we said, is a journey by itself. It keeps evolving, right? I would not say goalpost shifts, right? But as it evolves today, the number of models, the capability of the model, and the outcomes it can drive, it can be as simple as reducing the time it takes to diagnose a disease, right? That's a huge impact. Now, can you measure that in terms of life saved is equal to dollars saved? The answer is no, right? So business case is as important to figure it out and then say, hey, in my journey of AI, 2 years down the lane, this is the impact I needed to create. And then you can probably justify the investment, number one. It's quite philosophically, I just mentioned a bit on the cost of a life versus cost of ROI, but nevertheless, the ability of the underlying hardware to protect your investment throughout your journey, right? For an example, HPE and Intel collaborate together to bring you a compute platform that stay with you long time, right? It's a long term, right? Both support, both in terms of capabilities and whatnot. So that is one of the things that helps you to protect your investment. And last but not the least, the obsolescence is something that everybody is worried about. I start investing in a CPU today, then is it going to sustain tomorrow or not, right? So our partnership with HPE ensures that the platforms are compatible, right? For an example, when I say Xeon 6, there are two different CPUs, they are compatible. You can put them all in the same cluster, right? So that you can extend your lifespan. So that's a bit on the ROI and how do you look at it and how do we measure it as well, Anup?
Anup, I want to add here in what
Yes,
Suman
Sandesh.
said, right? When you look at ROI again, one of the issues that we see when people really talk about, the artificial intelligence and how important that has been is perhaps creation of very siloed approaches to AI, right? It's very project oriented, which means you're essentially creating intelligent silos, right? And that also causes one in terms of extended investment, and you're only having a very pointed approach to a problem, right? So what we are more or less seeing in the emergence of the experiences that people have is that people are trying to now take a platform approach to artificial intelligence. What does that mean? That means that you essentially get your data platform ready, and you could cook and churn out as many use cases as possible, and that will have a lifespan. Everything can change for every 18 months, perhaps every 12 months, perhaps. But if you have a right platform that you're not investing time and again on top of it, and also what we see is that artificial intelligence today has been seen as something that is used to drive more efficiency. But more or less in several entities, we are discussing things which are also looking in monetizing AI today. And that is a transition phase that we are also seeing in the marketplace. So that could also give you a significant idea in terms of, apart from ROI and hardware and stuff like that, we try our best to do that.
Mm.
But from a business standpoint, or if you take AI as an technology that's going to create an impact, I think organizations should look at what do they expect out of this technology and how that can be maximized, rather than just looking at finding out the difference between a cat and a dog.
I think very valid point, and organization looking at a project piece might not yield the complete benefit. And when you say a platform driven approach, obviously it has its advantages, and I'm sure as organizations are maturing, we won't be having intelligent silos. It's like equivalent to an amazing worker in an organization who is not passing on the knowledge to others.
Yeah.
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 And what's the point? The expertise remains with that person only. And it benefits a very small scale unit in the organization. It's in comparison to that. Meanwhile, I'll just request all the participants to whosoever is left to please answer the poll question. It would really help us understand your IT journey. Moving on, while we were talking about the the overall platformization of AI, when you are creating this, servers and processors play a very critical role. Sumant, you said that it is the base, where you need to kind of proof of your investment, when you have servers and processors. So how do AI workload necessitate an overhaul of these servers and processors? What role are they playing, and how do CIOs, tech leaders go on about upgrading these if there's needed, and where?
Great. If you look at the way AI has evolved, right? It was traditional classical machine learning, right? And then moved to deep learning. Now came the NLP, large language models, and then whole lot of subsets of the different model that can act on media, that can act on image, that can act on audio, or even for that matter, time series data that emanates from the edge, right? Now, irrespective of the type of data, irrespective of the use case, the AI has today evolved to a state where it can address, right? If you have a problem, it is capable of solving innovatively, right? Now, when you look at the way the AI, it was at inflection point where the enterprise workloads used to rule the roost, irrespective of on-prem or cloud or hybrid, right? So when I say enterprise, your mission critical enterprise application, whose data today you are harnessing for your AI insights, right? Now, the processors that are 2, 3, or 4 years old were created keeping those workloads in mind. It doesn't mean that we are not looking at those workloads. They are important, and they are also aggregated in today's CPU parlance. But AI, there was a point of inflection where they said, hey, AI characteristics or behavior of the AI workload demands different set of capabilities from the underlying platform, underlying server, more importantly, the CPU as well, right? So when you talk about AI, the accuracy matters, right? For everybody, the lofty goal is that AI becoming sentient, or it's going to replace you, or it is as accurate as a human being can be, or more accurate, maybe, right? So accuracy is important. So the moment you say about accuracy, it is about the number format that you use, right? How accurate it is. For scientific applications, we need more accuracy. For a chatbot, it is okay, just have to have the grammatical and syntax correct, right? Each one has a different requirement. Now, when you need that accuracy and speed, you need to empower the CPU. So today, at some point, when AI became the mainstream, or it became omnipresent everywhere, the CPUs also metamorphosized into what they are today, rendering specifically for your AI workloads. Apart from having number of cores, better frequency, higher cache, which all render, you need to have a subset within the CPU or a processor that cater to only to the AI workload, right? Both in terms of having data closer to the CPU, that which you're acting upon, the operations that you are trying to do on this data also to be closer on the CPU, and then also have the instructions that are modified or enhanced to provide processing faster. And you do all of this away from your main CPU cores. You free up the CPU cores, you offload that AI workload onto a specific accelerator, which we call as AMX, by the way, right? Now we aggregate all of that AI workload within the CPU, and then we have technologies that help you to accelerate the memory access by bringing up faster memory, faster PCI burst. More importantly, when you are collecting the data that you are training for your AI workload, from the network. We have accelerators that helps you to quickly gather that, right? Buffer it and gather it faster. More importantly, the storage, underlying storage, of course, we all know NVMe, so on and so forth. They are quite fast and capable of delivering that content. And amidst all of this, while you're ingesting the data, while you're accessing the data from your memory to the CPU or from the storage to memory to CPU, we have to ensure the security is taken care of. The surface of area of attack is reduced, right? So
Mhm.
we have built all those security capabilities right on chip. So you encrypt whatever comes onto the memory, done. Going into the CPU, it is encrypted. So nobody can spoof and get the data out. So security, performance, offloading the AI workloads onto specific CPU, all of them provide that capabilities. And thus, it warrants for looking at new platform, new CPU for your emerging AI workloads, as opposed to what you would probably be having in your data center, the older generation CPU, which are catering to your mission critical applications.
Got it. I think someone very well explained. In a sense, what you were saying was having the right infra, which helps you get the outcomes which you are looking at. It's not just about only the compute speed. It is how the data comes, how secure is the data, and how it is processed near to the edge, due to you having the correct servers and processors or most upgraded ones. Building on from this point, and while Sumant has very well explained how the data flows from a business angle, Rangasar, uh, it's very well known that these AI driven servers and processor, new age servers and processors improve performance by 30% almost, latency is reduced, and all the benefits are there. How do organizations go by identifying what needs to be upgraded? Where do they feel the need? Because they cannot have they need to assess where the need is, because obviously ROI, we just discussed a little while back, that is on their mind, while they need to have the agility and the scalability to get the benefit from these AI driven workloads. What do they need to upgrade? Where do they do that? That's the thought I want you to kind of give us insights on.
Yeah, that's again something that is a practical problem to many of us when you're looking at it. See, when you look at evolution of technology, you're going to see performance increments, the performance improvements for every generation, right? If you look at our Gen 11 Proliant servers, right, they are the best performing servers across multiple workloads today. Um, the way we try to look at it in terms of manifesting these improvements are across three different areas, right? One is to look at how can you make the server more efficient here. When you're talking of efficiency, it could be in terms of performance, it could be in terms of energy efficiency, or it could be in terms of how many cores you can put into a CPU, what is the IO bandwidth and stuff like that, right? Essentially trying to make more out of the real estate that's really available. And to that goes the CPU designing, the offloading chips, your ability to speak faster to data, all of things fall in place there. And then there is also about, how do you look at this I mean, there's energy as well. I forgot to mention, right? Because every generation that we change gets in that energy efficiencies, which ensure that you run an operating cost that is much lesser than what it was. And that could be one of the hooks today, right? If you're looking at generation to generation transformations, apart from the fact that, for an AI centric world, you need to have an AI centric architecture. If you're using some of this compute infrastructure for periods of time and it's not energy efficient, there could be a case that you have whereby just changing the number of servers, obviously because of the performance enhancements, you could have lesser number of servers. Obviously because of the efficiency in the power, you might have lesser power requirements, and your total cost of ownership might come down. And that return on investment that you're speaking of can happen. This is purely efficiency oriented. Um, then you have to focus from an acceleration perspective. The workload needs the acceleration today. And because of the kind of workload we talked about, parallelization of these workloads, you talked about massive data that's needed for these workloads to synthesize and effectively do that in real time. So you need to have all of that accelerated, right? AI ML today is part and parcel of a workload. And how do you do all of that? That's another aspect. The second thing that we look at the upgradability part is to keep it as open as possible in terms of the support, the ecosystem support that goes through for a given compute requirement, right? So we are part of the Open Compute project where standards, open standards is what we try and endorse to. Under these three heads, I see that organizations can look at when to upgrade and how to upgrade. But frankly, this all has to be tied up to a business paradigm, right? Business has to require the kind of output, and technology today drives business, and technology, better the technology, better is the outcome for business.
And I think you've already covered some bit of my next point, which was basically how do you future-proof your IT infra. Before we move on to that sections, we'll have another poll coming up. The poll question for the participants is, do they feel the need of upgrading their IT infra, and and if they need, at what capacity. This is again to understand, your IT journey and where are you actually feeling the pinch. And the question might be live at this moment as I speak. Now coming back to our next section, which is future proofing your IT infra for AI and other emerging technologies. And as Ranga sir had just mentioned that for an AI centric world, you need an AI centric infra. And very aptly put. Ranga sir, building on this point, Sumant, how do you go about, when I say you mean organizations, go about building this infra? When we say future proofing, you need to build this, keeping in mind the cost, keeping in mind the business paradigm. It has to be a business. How do you build this infra? How do you future proof it so that while you need to make investments continually, it doesn't become a very heavy burden on the organization? I'm sure these servers, processors, and IT infra do take up some bit of dollars. So the tech world are looking with the open eyes and ears to see to what extent they need to make the investment and how will they actually benefit from them.
Right. So Intel always has been belonging to school of thought that I would not want to disrupt the way you are doing things today. Right. When I bring a new technology, it should not spiral you into a new upskilling. Right. The microcode needs to be the same. The code that you are running on a previous generation should run on the upcoming generation. Right. That protects your investment. Number two. Number three, we always believed in open standards, not locking you in into a proprietary architecture, right? So, irrespective of you are running it on a private cloud or public cloud, or you are running an hybrid, your code is bound to run on an instance, on an Intel instance on cloud, or on your private cloud as well, on-prem, right? So that is number two. That is most significant for future-proofing your investment on technology. Number three, now while CPU, memory, and everything that I mentioned, and Rangas also mentioned about open compute platform, where we bring the interconnects and the interfaces that are more open, readily acceptable across the x86 platform as well, right? Now, beyond all this, what is more important for the customers to get embraced onto new technology or upcoming technology is that we ensure that we are at the inflection point of the every new workload. We ensure that we are a forward-looking architecture that renders seamlessly for your upcoming workloads. Many years ago, even today, people still use Hadoop and whatnot, data analytics. Today, people talk about data lakehouse, right? Because of the fact that you need to bring all the data at one place. Now, each one of these characteristics or a behavior or a changing demands of these workloads being CPU centric or core centric or frequency centric, whatnot, we ensure that commonality of the architecture moves along, right, as we bring up the roadmap, right? So this is how we ensure that the customer who want to invest in the new IT infrastructure stay invested and secure their investment that they are made on these platforms, right? For an example, when I say platform, the reason why I keep saying platform is that platform is not just the motherboard, platform is not just DL380, from HPE, it is not just that. The platform is the sum total of all the components, subcomponents, and the interaction that goes into it. All of them need to work together. So we ensure that the architecture is future-proof, including the interconnect, including the interaction, the subcomponents, so on and so forth, right? So we are the ones who say that, hey, the new memory is supported. Hey, 200 gig, 400 gig, 800 gig is supported. You need GPUs or AI accelerators. We have it on Intel platform, right? And you invest today, you are ensured of that code running elsewhere, everywhere else. So that's the commitment, that's the sort of approach that Intel take to ensure that your investment is protected and your inclination on a platform is protected over the long run.
I think very nicely explained. Building on from this point, and this, I hope people have answered the poll. I would again request webinar attendees to answer the poll. And we are now moving toward the last leg of our section. We've discussed a lot about how AI-driven workloads need AI-centric infrastructure, what kind of infrastructure, modular, scalable, as well as continual, if that is a correct word in the English language. It needs to be continued. Sumant, I learned from that. The answer you just gave us. But while it's all good in theory, real world cases are the ones which are actually hurt the most. Ranga sir, from your experience, and specifically when I put this question to you, I'm hoping if I have an India specific example, the attendees would be really interested in listening. How do, can you share an example from an India centric organization where they've modernized their IT infra, specifically made their infra a bit AI centric, and got the benefits, at a broader level, just to help them? It could be from any industry you feel. And then I'll come to you, Suman, post this.
Yeah. I mean, you rightly said, right? The IT landscape is well and truly changing. And we spoke about hybrid by design today, not by accident, where people just went to the cloud one day and then realized there is something left over in their data center and we have to manage both of them. That is where the emergence of hybrid by design becomes very important. It is your ability to stay in an hybrid mode and keep changing depending on the customer needs, etc., etc. So one of the things that I can remember is one of the large banks in the country, perhaps the largest, I would say, where they were essentially trying to modernize their entire infrastructure from a compute standpoint, specifically. They had kind of consolidated on the data footprint, but on the compute footprint, they had more number of servers. The typical customer problems was in terms of having more number of servers and servers which are relatively old in the context of the generations that we typically speak. The amount of power consumption that these machines were having was an issue, and also in terms of how do you cater to the emerging workload and make it very very relevant also was another issue. So they embarked on this entire effort of trying to resize and redefine the compute infrastructure landscape. And what the results were? The results were something which is jaw-dropping, I would say. They could essentially achieve a footprint reduction of 50 to 55%, which means if they had two servers, they could do it with one server. What did that mean? They meant, reduction in power, betterment of efficiency, availability of real estate, and multiple things that all got together to kind of define the return on investment for whatever change that they did. And most importantly, because we were setting up an architecture that was AI ready, and other term that I very frequently use is an edge to cloud architecture, which means that the IT landscape that's going to reside anywhere and everywhere needs to be connected and should be available. So they could essentially do this activity and very happy at the end of the day. They have a greener footprint, they have the right kind of performance, and they have essentially upgraded to a modernized compute requirement that it delivers to the business. A great example in the country, and like that, there are several others as well. I spoke of this purely because of the scale. We are talking of multiple servers, and we did it together with Intel.
I can very well imagine the scale, of a large bank. I'm not just naming it. I hope I guessed it. But 50 to 55% carbon footprint, I'm sure it can run into crores and crores of saving from an Indian aspect. And if this is possible from for a larger organization such as a bank that you mentioned, even same benefits would percolate down even for smaller organizations if taken at a
Yeah,
correct level, I'm
understood.
assuming. Sumant, passing the baton to you, when we are building on these specific examples, anything that you can think of where it has helped large or small organization, any specific industry?
Right. So I would probably piggyback on what Rangaswamy said. He mentioned edge to cloud. I would go back to the roots. So I'll probably go to the edge for a moment. Right. When one of the large conglomerates, which actually has renewable energies, including solar, including windmills, and so on and so forth. So their edge computing was very rudimentary. Right. It is very important for them to ensure the efficiency of the power generation is at peak. Right. Anything less than the expected power generation per day would demand for certain penalties, right? So it is important that the insights related to a large site is available right at the site at a remote location. Why should I send this data to the cloud or a data center to churn out and then take 30 minutes, 45 minutes for you to react and then take another hour to resolve the problem, right? So Intel architected a solution on Intel CPU, right? They were also of the opinion, hey, if you have to train this, we need GPUs. We said while GPUs are important for certain AI workloads or AI accelerators are important, you can actually run this on a CPU itself because, as I mentioned, we bought so much of accelerators, optimization, better instructions per cycle, and so on and so forth. We are able to deliver the business outcome right at the edge by telling that, hey, predictively, because of looking at the weather forecast, looking at the efficiency of the solar panel,
Mhm.
soiling of the solar panels, or shading on the solar panel, we used to tell them, hey, you are going to run out of power, or you will actually generate 10% less power if you don't take this corrective action. So predictively telling them has brought that efficiency onto their ecosystem faster, right? And we did this on a CPU without even having to go to an additional AI accelerator, right? This is one of the case, right? So somebody was asking that, hey, it is important that the use case, monetization of the use case is more important for us to get a ROI, right? Now imagine if you are able to predict a deterioration of the solar panel before it fails, 3 months before it fails, you have ensured that you have saved the cost, right? The cost of investment in your IT infrastructure is equal to the solar panel, one solar panel failing, right? So we already got a return on investment. This is number one. This is on-shore's use case that I want to talk about. Quickly, on bringing about a change in the population, I would like to quickly touch upon Siemens use cases. Now, Siemens, we worked with the Siemens to provide what we call as a tissue contouring, right? When I say tissue contouring, today there's so much of health issues pertinent to the cancer or malignancy of a particular tissue. Typically, what happens is the patient is subjected to computational tomography or CT scan, a 3D CT scan, and then subsequently MRI. And that report is actually sent to a radiologist. Radiologist looks at it and says that, okay, this is where the malignancy is. This is the boundary at which I should provide radiology, right? Or provide radiation, right? Because you have to do that. Now, it is very important and critical that you identify the boundaries through the layers of tissues and ensuring the organs adjoining to the malignant tissue doesn't get affected by the radiation, right? Now, that's a tedious and monotonous process that radiologists have to go through, right? And it will take a lot of time to do this, right? So in order to bring that efficiency, in order to take away the unnecessary time that the radiologist is spending on it, we have used, right, Intel AI optimizations on the CPUs by using what we call as an OpenVINO is one of the technology that we have where you can port your code wherever you want. And then using mixed precision data set, that is bfloat 16, running on the CPU, thereby reducing or bringing about 35 times better performance over previous generation of the processor. Because we put it on the latest generation, 35 times faster inferencing, number one. Number two, it is at 98% accuracy that it could tell that, hey, this is the boundary, right? This is the organ, right? That needed the contouring. So we were able to bring that faster by using latest processor and moving away from the earlier generation and upgrading to the new one. They were able to save on the data center footprint as well. The time to results became extremely fast and accuracy went up, thereby
Okay.
helping the healthcare or rendering better healthcare to the patient. So this is how AI can also impact
Mhm.
a person's life as well.
I think you gave two great examples. The first one where you're predicting and preempting the production loss, and second, obviously, the life is at stake and the accuracy helps. You already made the case for why investments in AI are really important. But now, summing up the overall discussion, moving to the final closing thoughts, Ranga sir. While Sumant has already made why AI investments in AI, compute architecture, servers, and processors actually matter, but to organizations and people who are attending, they're at crossroads, to be honest. They understand that these there are these benefits, but they also understand that it requires investments, it requires business backing. What would you say to those organizations, how to go about this, what kind of a broader approach they can take, which actually helps them achieve some of the things that Suman just described?
Yeah. Firstly, I think you cannot wait, right? You have to
Yeah.
start this journey. There is no better time than now. And if you're not doing it now, I think you can get lost. And it's very important that organization is taking advantage of a technology like artificial intelligence. As I said, it's a very profound technology. And in that context, getting your AI strategy right is also very, very important. Many people have jumped into the bandwagon for the sake of jumping in. But looking at it strategically with a 360-degree approach, I think is very, very important in getting your IT landscape ready. And in this successful strategy, there are three important components. One is your ability to have the right kind of data. Second is your ability to use the right kind of compute resource to ensure that the data is processed and you are able to get into insights from artificial, through AI. And there are models that really help to accelerate this process today, and the software stacks that are very, very prevalent. But in all of this, you'll have to get your people behind it. In the sense that you'll have to get your management committed to it. You'll have to convince them, coerce them, force them, do whatever it is. But you have to get into this bandwagon today. I think that is a call to action.
So if I were to give it an acronym, it would be a PDP, not the political party, but people, data, and processors.
Yes. Yeah.
If I were to, give it in that lingo. Any closing thoughts, Suman, from you?
Well, while I would say there's always an apprehension on what AI can bring to my workload, my organization. What is more important today is to find a ways and means to monetize this AI and help you to monetize, right? That's most important. Three, the impact that it would create and the impact that it should create is what you should vie for, and then work backwards in augmenting all the necessary moving parts, not just restricted to the servers, CPU, but also in terms of connectivity, rack, cooling, power, beyond. Looking at that from a longer perspective, you will see a return on investment and TCO benefit, as opposed to seeing it as a piecemeal science project that will cater to one of the small objectives. Then it tend to get lost in the quagmire of the corporate world, right? So it is important to finally identify and run objectively towards creating use cases that will create impact to you and monetize. And thus it is important the all those backing off the technology that we spoke about for last 1 hour is going to help you in that journey. So rest assured, it's not a bubble that's going to burst. It is going to be a ripple that's going to stay for a long for sure. Piggybacking on what Rangnath said a couple of minutes ago.
Thank you. I think you've already done the job of a closing line, Suman. It's not a bubble, it's a ripple. And as Ranga sir said, don't wait. You have to take the first dip. I would close the discussion with that thought, but a couple of points I want to make for everyone's benefit. We would be sharing the recording. It has been asked by multiple people, and I understand they have liked the discussion. So please be rest assured, in a day or two time, you will have an email with this. Sumant, a couple of people have also mentioned about the case study, and Ranga sir, you as well. So I might reach out to you after this, if it's possible, to share some anecdotal things. We will discuss that on an email. Thank you everyone for such an engaging discussion. Yes, Mr. Vishwanathan, I would discuss with Sumant and Rangasan, and we would share specific things. I'm sure we've shown it on the screen, so we can share some parts of it. But just give us a day or two. We have all of your email IDs and your contact details. Hope you've given us. If you're not, please give us that if that's missed out, so that we can share the case study. Thank you, Ranga sir. Thank you, Sumant sir. Thank you so much for this engaging and in-depth and insightful discussion. Thank you.
Thanks,
Thank you,
everybody.
Anup.
Have a
Thank
great
you so much.
evening. Bye-bye.
Bye-bye.